So here was the first question I got with an email, and I'll be honest, I'm just a little bit confused because it asks in the text part, it says, how does the derivative of sine of 7x over 4x equate to 7/4? But then on the handwritten example, it just says find the limit of sine of 7x over 4x equals 7/4. Well, the derivative doesn't equal 7/4 because the derivative is not going to be a constant. Okay, so I think it was just maybe a poor choice of wording or some other confusion or whatever. Okay, but we could find the derivative of it, or we could find the limit of it. In fact, maybe I'll just do both because you got to find derivative of stuff like this anyway. Okay, so let's just ignore the handwritten part and let's just look at the derivative of sine of 7x over 4x, and we want the derivative of that. Okay. So if I were finding the derivative of that, and this is something that you're going to be coming up on soon, this is why I think probably not, but it's a good preview, okay, that you need to use what's called the quotient rule. Okay. So the quotient rule for derivative says if you have some function, says if you have some function f of x that's equal to, let's say, g of x over h of x, that the derivative of that is the derivative of the numerator times the derivative of the denominator times the numerator minus the numerator, the derivative of the numerator times the denominator over the denominator squared. Okay? So to find the derivative of this, I want the derivative of 4x, which is just 4. So we'll do 4 times sine of 7x minus, and 4x, now we have to multiply by the derivative of the numerator, which is going to be 7 times the cosine of 7x. And I use the chain rule for that. Divided by, and then the 4x squared. So I could simplify just a little bit, say we got this minus 28x cosine of 7x over 16x squared. And we could reduce, of course, because these three things are all divisible by 4. And we're going to wind up with sine of 7x minus 7x cosine of 7x all over 4x squared, and that would be the derivative. Okay, but I really think that was just kind of a bad choice of wording, but I thought, hey, you know what? You're going to be doing quotient rule stuff soon anyway, so why not? Okay. Now, to find the limit of that, okay, so again, I don't know what section this is coming out of, so I don't know exactly what technique would be expected, in a particular section or something, okay? Typically, the first thing to try is making a substitution. So if you do sine of 7 times 0 over 4 times 0, what happens? Okay. Well, that's just sine of 0 over 0. Okay. Now, sine of 0 happens to also be 0. This is indeterminate. Okay? It's what we call an indeterminate form. It's not undefined. Okay? It's we don't know. Okay? Think of it this way. If you have 0 divided by any number, you get 0. Okay? So if 0 is in the numerator, you typically get 0. But if 0 is in the denominator, you get something that's undefined. So we almost have a choice of what's going on. And that could be an issue. In order to answer these indeterminate forms, where we have that, the easiest way to do that is to use L'Hopital's rule. Okay. Now, L'Hopital's rule says if you have an indeterminate form, then you can look at the limit, in this case, of the derivative of the numerator divided by the derivative of the denominator. Okay? So that slope equals what? You're not doing the derivative of the quotient and not using a quotient rule, okay? But you're looking at the derivative of just each piece. Well, the derivative of sine of 7x is 7 cosine of 7x. The derivative of 4x is just 4. Now, if I try to evaluate that at 0, we're going to get 7 times cosine of 0 over 4, but cosine of 0 is equal to 1, so that is just 7/4. So I would use L'Hopital's rule if I saw that. However, if you haven't gotten to that yet, and I don't know where you're at in this for this particular question, then the easiest way to do it is maybe to start making a table and see if you can spot what it becomes closer and closer to as x gets closer to 0. So you might just want to consider making a table and seeing if you can spot the pattern.